Hey, Algebra 2, we're going to learn how to do nth roots and simplify some radicals today. So if you have a radical that looks like this, the n is called the index, and the a is called the radicand. If you have the square root of 5, if there is no number right here where this n is, that means that's an implied 2, and your index is a 2. If we want the index to be anything else, we would have to write it there. Like if we wanted to take the cube root of 7, we would have to actually write it there, and in that case, your index is 3. So the index is the number in this little notch part of it. All right, so we have some information here, but if we're going to focus probably on this section of it today. So if you wanted to, we can move back and forth between exponential form and radical form. And the big takeaway here is that the index is the denominator. So if you have a to the m over n power, if you were to rewrite it in radical form, whatever this denominator of the fraction is, that's always what the index is. So if I wanted to rewrite this radical using exponents, that means that I have an invisible index of 2, and this would be 15 to the 1/2 power. So maybe you're asking, where did you get that 1? So if there's no there's no number there, then you need a placeholder, and there's an implied 1 there. So if you have 7 to the 1/2 power, that means the 2 is your index, and so that I could just write as the square root of 7. This is the cube root of 17, so that is 17 to the 1/3 power. The index is the denominator. So 18 to the 1/3 power is the cube root of 18. I have 16 to the 2/3 power. The denominator is your index, so I have the cube root of 16 squared. So this one has something other than a 1, so we are going to have to square it. If I have the cube root of x to the 2nd power, that is x to the 2/3, because the index is the denominator. The index is the denominator, so 7 is my index. So that's the 7th root of m to the 5th. Ooh, this one. All right, so each one of them is going to be written as something to the 1/3 power. So I have 12 to the 1/3. The x is going to have to be written separately. So that means that I have x squared to the 1/3. Okay, so let's clean that up. And 2 times 1/3, I didn't really mean to do that. That is x to the 2/3 power. Y has an implied 1 on it, and that is y to the 1/3 power. So now we're going to learn how to simplify radicals. And we're mainly going to be dealing with square roots, cube roots, and 4th roots. So it's helpful to know what your perfect squares, cubes, and fourths are when you're simplifying something. So if I have 2 to the second power, that would be 4. So 4 is a perfect square. What are my other perfect squares? You could just kind of write them out like this and list them. So 3 squared is 9. 4 squared is 16. 5 squared is 25. 36. 49. 64. 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. So there's my first 12 perfect squares, which is a good idea to memorize. So why is this important to know? Well, you could either say the square root of 2 squared, so radicals cancel out exponents, and you can know that it's 2 that way, or you could know that the square root of 4 is just simply 2, because 2 times 2 is 4. So you could do this many ways. What are my first couple perfect cubes? I don't know. 2 to the third power is 8. So that means that the cube root of 8 equals 2. You could also think of it as 8 can be broken down into 2 times 2 times 2. So sometimes I teach how to take these by whatever your index is, making groups of 3. So if you can make a group of 3, then that means that the answer is 2. What are other perfect cubes? Let's see. 3 cubed. 3 times 3 is 9, times 3 is 27. 4 cubed. 4 times 4 is 16, times 4 is 64. And 5 cubed, I can tell you, is 125. So even if you don't memorize your perfect cubes, this is how you can create them. What are my perfect fourths? So if you have 2 to the 4th power, I know that that is 16. 3 to the 4th is 81. And 4 to the 4th is 256. So it's a good idea to know what your perfect square, cube, and fourth roots are. So now we're going to simplify them. So that means we have to take the square root of 49a to the 8th. Taking the square root of the variable is pretty easy because 49 is a perfect square. The square root of 49 portion is 7. And then for exponents, for variables, you take your exponent divided by the index. So 8 divided by 2, so there's no index there, so that means there's an implied 2 there, equals 4. So the answer here is 7a to the 4th. What's another way that we can do it? You could, since your index is 2, you could make groups of 2. So I have the square root of a to the 8th power. So that means that I have 8 a's under the radical. 1, 2, 3, 4, 5, 6, 7, 8. All right, so how many groups of 2 can I make? I can make 4 groups of 2 with none left over. So that's how I get a to the 4th power. All right, let's do another one. All right, now I'm on cube roots, and it doesn't look like I have a perfect cube there. So what are my perfect cubes? So 2 to the 3rd power is 8, and 3 to the 3rd power is 27. So when I'm looking at my numbers under the radical, I'm asking what factors of 16 are perfect cubes. And so 8 is a factor of 16. So let's rewrite this as 8 times 2. I can take the cube root of 8, which is 2. Now, when it comes to my variables, so a to the 6, remember that we take the exponent divided by the index. So that means that I have 6 divided by 3, which equals 2, with none left over. So I have 2 a's that I can pull out of the radical. And then I have b to the 9th. You take the exponent divided by the index. 9 divided by 3 is 3. That means that I can pull 3 b's out. And then I never did anything with this leftover 2. And so it is going to stay under the radical. So that is how you simplify a cube root. Number 11. I have a 48 here with an index of 4. So what are my perfect fourths? Let's see. So 2 to the 4th equals 16. And I do know that 16 goes into 48 3 times. So I would rewrite this as 16 times 3, x squared, y to the 4th, z to the 12th. So I know I'm going to take the 4th root of 16, so that means that a 2 is going to come out of the radical. I have x to the 2nd. So when it comes to variables, your exponent has to be equal to or greater than the index in order for any of the variables to come out of the radical. So my index is 4, and this exponent is too small. I can't do anything with it. So the 3 is going to stay under, and the x squared is going to stay under. Y to the 4th. Okay, so that is the same as my index. So 4 divided by 4 equals 1. So that means that 1y can come out from under the radical. And z to the 12th. 12 divided by 4 equals 3. So that means 3 z's can come out. All right, so then I circled that because that came out. I still have a 3 and an x squared left under the radical that I couldn't do anything with. And so that is now a fully simplified radical.